Picture this. 700 million years ago, the sun rises over an ocean you would not recognize. The light is pale, thin. It filters down through a sheet of ice so thick you could stack 3 Empire State Buildings on top of each other and still not reach the surface. There is no sound, no waves, no wind, no birds, because there are no birds yet, no footsteps, because there is nothing here to walk, just silence. The kind of silence that makes you wonder if the universe forgot this place existed. Beneath the ice, a mile down, the water is black, cold enough to stop your heart in seconds. And in that darkness, clinging to a crack in the ocean floor, near a volcanic vent, there is life. Barely, a few clusters of bacteria, stubborn little things. They do not know they are the only ones left. They do not know the entire planet has frozen over. They just continue, dividing, surviving, waiting for something they cannot imagine. This is Earth, our Earth. Not almost ended in the way we talk about climate change or nuclear war. I mean ended. As in, the story stops, the lights go out, nothing grows, nothing evolves, no dinosaurs, no humans, no one left to wonder what happened. And here is the thing that keeps me up at night. This was not a freak accident. This was not a one-time near miss. Earth has almost become uninhabitable at least 5 separate times. 5 times the planet came so close to giving up that if you change just one small variable, one volcanic eruption, one asteroid trajectory, one mutation in a single bacterium, none of us would be here. You would not be lying in bed right now, listening to this. I would not be sitting in a quiet room at midnight, telling you about it. There would just be nothing. A frozen rock, or a burnt one, or one choked in poison gas, spinning silently around a star that no longer matters. So, tonight, I want to take you through those 5 times, not as a science lesson, not as a lecture, but as a story. Because that is what this is. It is the story of how we almost were not, and somehow, against odds so slim they make winning the lottery look like a sure thing, we made it. My name is Mr. H. And if you are here, it is probably late. Maybe you cannot sleep. Maybe the world feels a little too loud, or a little too heavy. Or maybe you just need something that feels real, something bigger than tomorrow's problems. I make these videos for nights like that. You do not have to do anything. You do not have to take notes or remember facts or be inspired. You can just listen. You can just be here. And if you fall asleep halfway through, perfect. That is exactly what this is for. Now, before we go any further, let me say this. If you are using this to help you wind down, maybe turn your screen off. Or at least dim it. Let the words do the work. And if this becomes a space you come back to, a little corner of the internet that feels like home, you could hit subscribe. Maybe drop a comment and tell me where you are right now and what time it is. I love knowing there are people all over the world listening to the same story. All of us awake when we probably should not be. But no pressure. Just being here is enough. All right, let us begin. We are going to walk through 5 events. 5 mass extinctions. 5 moments when the music almost stopped. Snowball Earth. When the entire planet froze solid for millions of years. The Great Dying, when 96% of all life vanished in what might be the worst catastrophe in Earth's history. The asteroid that killed the dinosaurs and nearly everything else. The oxygen crisis, when the air itself became poison, and a gamma ray burst, a beam of radiation from space so powerful it could sterilize half the planet in seconds. We do not even know for sure if that last one happened, but the evidence suggests it might have, and it could happen again. These are not just disasters, they are transformations. Moments when Earth had to decide, in its slow, geological way, whether to keep going or give up. And every single time, by the thinnest of margins, it chose to continue. But here is what I want you to understand. This is not a story about triumph. It is not about humanity's greatness, or life's unstoppable will, or any of that. It is smaller than that. Quieter. It is about bacteria that did not know they were important. About creatures that survived not because they were strong, but because they were small enough to hide. about luck, about timing, about the fact that sometimes the thing that saves you is the same thing that could destroy you, because that is the truth, is it not? Survival is not clean. It is not fair. It is not a reward for being good, or smart, or brave. It is just continuation. One day after another, one breath after another, until suddenly, millions of years later, here you are, and I think that matters. I think it matters that you are the product of a billion small moments that went right, that every person who came before you, all the way back to those bacteria under the ice, made it through their own version of the worst day imaginable. They did not have to be heroes, they just had to be stubborn, lucky, willing to see one more sunrise. So tonight, we are going to visit those moments. We are going to stand at the edge of the world and look down into the dark, because we always have. Let us start with the coldest place Earth has ever been. Let us start with the ice. 720 million years ago, Earth looked nothing like the pictures you have seen. There were no green continents, no polar ice caps in the way we know them. Most of the land was clumped together near the equator, bare rock and sand, baking under a younger, slightly dimmer sun. And the oceans, those ancient seas, were full of life. Not the kind of life you would recognize. No fish yet. No plants. Just microbes. Bacteria. Algae. Tiny, invisible things drifting in the warm water, eating sunlight, multiplying. It was quiet. Simple. But it was alive. The temperature was mild. Comfortable, even. If you could have stood on one of those rocky shores, you might have felt a warm breeze, seen gentle waves lapping at stone that had never known a footprint. The sky was a different colour back then. More orange, maybe. Less oxygen meant less blue. But it was still a sky. Still a world. And then, slowly, quietly, without anyone noticing because there was no one to notice, it started to change. It began at the poles. It always does. Ice is patient. It does not rush. It creeps. Maybe it started with a cooler summer, a volcanic eruption that threw ash into the air, blocking just a little bit of sunlight. Or maybe the continents shifted in a way that changed the ocean currents, redirected warm water away from the poles. We do not know exactly, but something tipped the balance, and once ice starts to form, once it gets a foothold, it feeds itself. Here is how it works. Ice is white. White reflects sunlight. The more ice you have, the more sunlight bounces back into space instead of warming the planet. So it gets colder. And when it gets colder, more ice forms, which reflects more light, which makes it colder still. It is called the albedo effect. A feedback loop. And once it starts, it is very, very hard to stop. So the ice spread. From the poles toward the equator. Inch by inch, mile by mile, year by year. The oceans froze from the outside in. First a skim of ice at the surface, then thicker. A foot, 10 feet, 100 feet, until the ice was a mile deep in places, covering the entire planet like a shell. Snowball Earth. That is what scientists call it now, though honestly, the name does not quite capture it. A snowball sounds temporary. Fun, even. Something you throw and it melts. This was not that. This was the planet holding its breath for 10 million years. Maybe longer. We are still not entirely sure. Imagine it. Imagine being one of those bacteria drifting in the ocean when the freeze began. You do not have a brain. You do not have thoughts. You do not know what cold is, but you can feel it. In whatever way a single-celled organism feels anything, the water around you getting thicker, slower. And then one day, it stops moving altogether. You are trapped, not dead. Just frozen in place, suspended, waiting in the dark beneath a ceiling of ice so thick that no light reaches you. No photosynthesis, no food, just cold and silence. The kind of silence that makes you wonder if the universe forgot this place existed. Most life died, of course. How could it not? When the oceans froze, when the sunlight disappeared, when the temperature dropped so low that even the equator was below freezing, there was nowhere to go, nowhere warm, nowhere safe. The bacteria that had filled the seas, that had spent billions of years learning how to survive, found themselves in a world that no longer wanted them, and they died. Not all at once, not dramatically, just slowly, quietly. One by one, the little fires went out. But not all of them, because here is the thing about life. It is stubborn, unreasonably stubborn. Even when the odds are impossible, even when every logical outcome says it should end, life finds the margins. The places that are just barely livable. Deep beneath the ice, at the bottom of the frozen ocean, there were volcanic vents, cracks in the ocean floor where the planet's heat still leaked out, hot water, rich with minerals, bubbling up into the freezing darkness. And around those vents, in those tiny pockets of warmth, life continued, not thrived. Continued. A few species of bacteria, maybe a handful of other microbes, huddled together in the only place left where the water was still liquid, where there was still heat, still chemistry, still a chance. They did not know they were the last ones. They did not know the entire planet had frozen, surviving on whatever scraps of energy they could find, holding on for 10 million years. Think about that for a second. 10 million years. That is longer than humans have existed, longer than most species exist, period. 10 million years of darkness, of cold, of nothing changing, just the slow drip of time, stretching out so long it stops meaning anything. What does it feel like to wait that long? What does it mean to survive when no one is watching? When there is no reward, no purpose, no story being told about your resilience? It just is. You just are. I think about those bacteria sometimes. Late at night, when I cannot sleep, when everything feels too big or too pointless or too uncertain, and I think they did not have hope. They did not have a plan. They did not know it would get better. They just kept going because stopping was not an option their biology allowed. And somehow that helps. Knowing that survival is not always about courage or faith or vision. Sometimes it is just about continuing. One more day, one more division, one more moment of not giving up, even when giving up would make more sense. But here is the question that keeps scientists up at night. How did it end? How do you unfreeze a planet? Because once you are in a snowball state, once the ice has taken over, the normal processes that warm the Earth stop working. The sun cannot heat the surface because the ice reflects it all away. The oceans cannot absorb carbon dioxide because they are frozen solid. It should be permanent. A trap with no exit. Except for one thing. Volcanoes. Volcanoes do not care if the surface is frozen. They do not need sunlight or oceans or atmosphere. They run on heat from deep inside the planet. Heat left over from Earth's formation. Heat from radioactive decay in the core. And they do not stop. So even while the surface was frozen, even while the world was silent and still, volcanoes kept erupting. In Iceland, in what would one day be Siberia, in a dozen other places, lava pushed up through cracks in the ice, created lakes of slush. And most importantly, it released carbon dioxide. Carbon dioxide is a greenhouse gas. It traps heat. Under normal circumstances, rain and oceans absorb it, keep it balanced. But when the oceans are frozen, when there is no rain because all the water is locked up in ice, the carbon dioxide just builds up, year after year. Eruption after eruption. For millions of years, the volcanoes pumped gas into the sky. Slowly, invisibly, the atmosphere thickened, got heavier, started trapping more and more of the sun's heat. And then, one day, somewhere near the equator, the temperature rose just above freezing. The ice started to melt, not all at once, not everywhere, just a crack, a thin line of open water, a place where the sun could finally touch the ocean again. And once that happened, the whole process reversed. Less ice meant less reflection meant more warming meant more melting. The feedback loop that had frozen the planet now worked in the opposite direction. thawing it out. Within a few thousand years, geologically speaking, an eye blink, the ice was gone. The oceans were liquid again. The sun shone on open water, and the planet, which had been holding its breath for 10 million years, finally exhaled. But here is the beautiful, strange, unexpected part. Life exploded. Those few bacteria that had survived, those stubborn hangers-on huddled around the volcanic vents, they came out into a world that was brand new, empty, wide open, no competition, no predators, just space, endless space to grow and evolve and experiment. And they did. Within a few million years, you start to see the first complex life, the Ediacaran period. Strange, soft-bodied creatures that look like nothing alive today. Fronds, quilts, discs, things that might have been animals or might have been something else entirely. We still do not really know, but they were here. They were new. Sometimes the thing that nearly kills you is also the thing that makes you possible. I find that comforting, in a strange way. The idea that catastrophe is not always the end, that sometimes it is a clearing, a blank page, a chance for something different to begin. Because the truth is, if Snowball Earth had not happened, you and I would not be here. The evolutionary pressure of the freeze, the bottleneck it created, the explosion of diversity that followed, all of that set the stage for everything that came after. Complex cells, multicellular organisms, animals, plants, us. We are here because the world froze, because a few microbes were stubborn enough to wait it out, because volcanoes do not stop, because ice eventually melts. That is the first lesson, I think. The first thing the Earth teaches us when we look back at these near misses, that the planet does not care about individuals. It does not care about comfort or fairness or making sense. And if you can continue with it, even barely, even in the dark, even when everything seems hopeless, sometimes that is enough. Sometimes survival is not about being the strongest or the smartest or the most prepared. Sometimes it is just about being in the right crack at the right time and holding on and waiting. The bacteria under the ice did not know they were heroes. They did not know they were carrying the future of all complex life in their simple, unremarkable cells. They just kept going because that is what life does. And here we are, billions of years later, still going, still holding on. Now, I want to pause here for just a second. Feel the weight of your head on the pillow. Feel your breath, in and out, slow and steady. You are warm, you are safe. The world outside is not frozen. The air you are breathing is full of oxygen. The sun will rise in a few hours, and it will be bright and warm and completely ordinary. These are not small things. They are everything. All right, let us keep going. Because the ice was not the only time Earth almost gave up. Not even close. Next, we are going to visit the worst day in the history of life on this planet. A day when 96% of everything died. When the oceans turned to acid and the sky rained poison, and the few creatures left alive must have thought they were living through the end of the world, because they were. But first, rest your eyes if you need to. Settle in. We have time. We have all the time in the world. 252 million years ago, the world was loud. I want you to understand that first. Before we talk about what happened, before we walk through the fire, I need you to know what was lost. Because extinction is not just about death. It is about silence, about the absence of sound that used to fill the air, the Permian period. Late Permian, to be specific. This is about 40 million years before the first dinosaurs. The land is covered in forests, but not forests like you know. These trees are strange. Massive seed ferns with fronds the size of your living room. Conifers that look almost familiar until you get close and realize nothing about them is quite right. And beneath them, moving through the shadows, are creatures that do not fit into any category your brain wants to put them in. Reptiles, technically. But that word does not do them justice. There are sail-backed predators the size of grizzly bears, with teeth like steak knives and skin that is probably warmer than you would expect. There are herbivores built like tanks, low to the ground, armored, munching on ferns with the kind of focus that suggests they have been doing this for millions of years and see no reason to stop. The air hums with insects, dragonflies with 2-foot wingspans, beetles the size of your fist, millipedes as long as your arm, clattering through the leaf litter like biological trains. And the oceans. God, the oceans. Reefs built not by coral, which does not really exist yet in the way we know it, but by strange calcified sponges and algae, forests of crinoids, those flower-like animals that look more like plants. Trilobites, those ancient armored arthropods that have been around for 300 million years at this point, still going strong, scuttling across the seafloor like they own the place, which, in a way, they do. The world is full. Confident. Life has figured out how to live in every corner, every niche, every possible space. The planet is humming with it. And then, in what is now Siberia, the ground starts to crack. Not everywhere. Not all at once. Just in one spot. A weak point in the crust. A place where the pressure from below has been building for millennia. And when it finally breaks, when the lava starts to push through, it does not stop. This is not a volcano in the way you picture it. Not a mountain with a cone, spewing ash and lava for a few weeks before going quiet. This is something else. This is the Siberian Traps, and it is going to erupt, on and off, for 2 million years. 2 million years. Let me put that in perspective. 2 million years ago, the earliest humans were just learning to make stone tools. All of recorded history, everything from the pyramids to the moon landing, fits into the last 5,000 years. 2 million years is almost incomprehensible. It is geological time, deep time, the kind of time that makes human lifespans feel like camera flashes. And for all of that time, lava floods out across the landscape, covering an area the size of Western Europe, miles deep in some places. The heat is unimaginable. The glow would be visible from space if there were anyone in space to see it. And with the lava comes gas. Carbon dioxide, mostly, but also sulfur dioxide, methane, chlorine, a toxic cocktail pumped into the atmosphere day after day, year after year, century after century. The temperature starts to rise. At first, maybe it is not so bad. A few degrees, warmer summers, milder winters, the kind of change you could adapt to if you had time. But the eruptions do not stop. The gas keeps building and the temperature keeps climbing. 5 degrees, 10 degrees. In some places, near the equator, it gets 15 degrees hotter than it was before. Now, you might think, 15 degrees, that is not the end of the world. That is the difference between a cool day and a hot day. But we are talking about average global temperature, 15 degrees warmer everywhere. All the time. Forever. That is the difference between an ice age and a greenhouse. That is the difference between livable and not. The forests start to die. The soil dries out, turns to dust. And the animals, those confident, successful creatures that had ruled the land for millions of years, start to struggle. But the real horror is happening in the ocean. Because here is what warm water does. It holds less oxygen. The hotter it gets, the less gas it can dissolve. So as the temperature rises, the oxygen in the ocean starts to drop. And the creatures living there, the fish, the invertebrates, the microbes, they start to suffocate. Not quickly, slowly, over generations. They get sluggish, smaller, less able to reproduce. And the ones that live in deep water, where oxygen levels were already low, they die first. And when they die, they sink. Their bodies pile up on the ocean floor, and bacteria move in to decompose them. Bacteria that do not need oxygen. Bacteria that produce hydrogen sulfide as a waste product. Hydrogen sulfide. The smell of rotten eggs. Toxic to almost everything. And it starts to build up. At the bottom of the ocean first, then rising, spreading, turning the water into a poisonous soup. The ocean is suffocating from the bottom up, and then, because the universe has a cruel sense of timing, the methane starts to release. Methane hydrates, frozen pockets of gas trapped in the sediment at the bottom of the ocean. They are stable when the water is cold, but when it warms up, they melt. And when they melt, the methane bubbles up to the surface and enters the atmosphere. And methane is a greenhouse gas, a powerful one, much stronger than carbon dioxide, so it traps even more heat, which warms the ocean even more, which releases even more methane. Another feedback loop, another runaway process. And once it starts, there is no stopping it. The temperature spikes, the ocean acidifies, because all that carbon dioxide is dissolving into the water, turning it into weak carbonic acid. The reefs dissolve, the shells of countless creatures start to thin, to crack, to fall apart, and the hydrogen sulfide, that poison from the deep, finally reaches the surface. It bubbles out into the air. Toxic clouds drift across the coastlines, and anything living near the shore that has not already died from the heat or the starvation or the lack of oxygen now has to deal with breathing poison. 96% of marine species go extinct. 70% of land species. The worst mass extinction in Earth's history. Worse than the asteroid that killed the dinosaurs. Worse than anything before or since. And here is the thing that gets me. The thing I cannot stop thinking about. It did not happen in a day, or a year, or even a century. It took tens of thousands of years, maybe 100,000. We are still not sure, which means there were generations of creatures that lived and died in a world that was visibly, measurably getting worse. Year after year. The summers hotter, the winters harsher, the food scarcer, the air harder to breathe. They did not know why. They did not have scientists or historians or anyone to explain that Siberia was on fire and the carbon cycle had broken and the ocean was turning toxic. They just knew that life was harder than it used to be, that their parents had it easier, that something fundamental had changed, and they kept going anyway. They kept reproducing, kept trying, kept adapting as best they could. What does that feel like? To be part of the last generation, to watch your world end in slow motion and not understand why? I do not know. Because here is the truth. Most of the creatures that died in the Great Dying were not weak. They were not failures. They were successful species that had been around for millions of years. The trilobites, for instance, 300 million years they had survived. Every previous mass extinction, every ice age, every shift in sea level or climate or predator. They had seen it all and adapted to it all, and then they were gone. Not because they did something wrong, not because they were unfit, just because the planet changed faster than they could keep up. And sometimes, no amount of adaptation is enough. That is a hard lesson. Maybe the hardest one. That you can do everything right and still lose. That survival is not always about merit or effort or deserving. Sometimes it is just about luck. So who survived? Not the strong, not the apex predators or the most specialized or the most intelligent. The survivors were small, generalists, creatures that could eat almost anything, live almost anywhere, tolerate almost any condition. On land, there was a creature called Lystrosaurus, a squat, pig-like reptile about the size of a large dog, ugly, honestly, blunt snout, short legs, no impressive teeth or claws or armor, just a tough little digger that ate plants and could burrow underground when things got too hot or too cold. Not glamorous, not impressive, but stubborn. For a while, maybe 1,000,000 years after the extinction, Lystrosaurus made up 95% of all land vertebrates. The same species, over and over, inheriting an empty world. They were not the best. They were just the ones left. And slowly, painfully, over millions of years, life started to rebuild. New species evolved from the survivors. New ecosystems formed. The carbon cycle stabilized. The oceans recovered. The forests grew back. But it was not the same world. It could never be the same. The trilobites were gone. The massive reefs were gone. Entire branches of the tree of life. Millions of years of evolutionary experimentation. Quieter in some ways, louder in others. Because here is what filled the gap. Here is what evolved in the empty space left by the great dying. Dinosaurs, mammals, eventually birds, eventually us. We exist because 96% of life died, because the world burned and suffocated and poisoned itself, because a few stubborn, unremarkable creatures held on when everything else let go. I do not know if that is comforting or terrifying. Maybe both. There is a kind of loneliness to it, I think. The idea that the world we know, the diversity we see, the ecosystems we depend on, all of it is built on top of graveyards. That every forest is growing in soil enriched by 1 billion forgotten deaths. That every breath of air is a gift from organisms that suffocated so we could eventually evolve lungs to breathe it. We do not like to think about that. We like to think of nature as stable, permanent, a backdrop that will always be there. But it is not. It never has been. The normal we experience is just a moment, a brief pause between catastrophes, a window of time when the temperature happens to be right and the oxygen happens to be sufficient and the planet happens to be calm enough for complex life to thrive. And that window can close. It has closed before. But here is the thing. Here is the small, stubborn, unreasonable thing that keeps me going. The window always opens again, maybe not for the same creatures, maybe not for millions of years, but it opens. Life does not give up, even when 96% of it dies, even when the ocean turns to poison and the air fills with sulfur and the temperature spikes beyond what any complex organism should be able to tolerate. That 4% holds on, and it rebuilds, not because it is noble or brave or destined, just because that is what life does. It continues. It adapts. It finds the cracks and the margins and the barely livable spaces, and it makes them home. The Lystrosaurus did not know it was saving the world. It was just trying to get through another day, trying to find food, trying to survive one more season. And that was enough. Maybe that is all any of us can do. Get through another day, another season, another hard moment, and trust that continuation, in itself, is meaningful. That showing up, even when the odds are impossible, even when the world is visibly falling apart, is not futile. It is how we got here. It is how anything gets anywhere. So take a breath. A deep one. Feel the air fill your lungs. That air is a miracle. A gift from the 4%, from the stubborn ones, from the creatures that refuse to let the story end. You are breathing the same planet they breathed. And you are still here. So was it worth it? All that suffering? All that death? I do not know. I do not think the universe keeps score like that. I think it just is. And we are. And maybe that is enough. Let your eyes close if they want to. Let your body sink into the mattress. We are halfway through now. Halfway through the darkest moments. And you are doing fine. You are exactly where you need to be. Next, we're going to talk about a different kind of ending. A faster one. One that came from the sky without warning and changed everything in an afternoon. But for now, rest. Breathe. You have earned it. 66 million years ago, on a Tuesday morning in what we now call the Yucatan Peninsula, a triceratops woke up. I say Tuesday because why not? It was some day, some ordinary day, the kind of day that feels like every other day. The sun came up the way it always did. The air was warm, humid, the smell of flowering plants and wet earth, and something rotting somewhere in the underbrush. The triceratops, let us call her Sarah, though she did not have a name and would not have cared if she did, was hungry. She was always hungry. That is what happens when you weigh 6 tons and eat plants. You spend most of your waking hours chewing, so she walked to a stand of ferns she had been working on for the past few days. Low-growing, tender, easy to crop with her beak. She settled in, started eating. The rhythm of it, bite, chew, swallow, bite, chew, swallow, probably felt like meditation, like the most important thing in the world. A few miles away, a Tyrannosaurus was sleeping off a meal. Somewhere overhead, a pteranodon circled, riding the thermals, barely flapping, just gliding. waiting for something dead to appear below. It was a normal day. The dinosaurs had been here for 160 million years. They had survived ice ages and volcanic eruptions and continental drift and every other thing the planet could throw at them. They were not going anywhere. They owned this world. It would always be theirs. And then, at roughly 10:46 a.m., the sky caught fire. Here is what happened. An asteroid, about 6 miles wide, roughly the size of Mount Everest, had been traveling through space for billions of years, just drifting, following the gravitational pull of the Sun and Jupiter and 1,000 other objects, its path bending and shifting in ways too complex to predict. And on this particular day, on this particular orbit, its trajectory intersected with Earth. It entered the atmosphere at 45,000 miles per hour, faster than anything you can really comprehend, faster than a bullet, faster than sound, so fast that the air in front of it did not have time to move out of the way. It just compressed. And when air compresses that quickly, it heats up. The sky turned white, brighter than the sun, bright enough that if you looked at it, your eyes would have burned out of your skull before you had time to look away. But no one looked away, because no one understood what they were seeing. The animals on the ground, Sarah the Triceratops, the sleeping T, Rex, the circling Pteranodon, they just saw light, impossible light, and for maybe 3 seconds. And then it hit. The impact released more energy than 1 billion nuclear bombs, more energy than every volcanic eruption in human history combined. The asteroid vaporized on contact. The rock beneath it vaporized. A crater 12 miles deep opened up in less time than it takes you to blink. A wall of superheated rock and gas exploded outward at several thousand degrees. Everything within 1,000 miles was incinerated instantly. The trees, the animals, the soil, the water, everything turned to ash and plasma and scattered across the continent. The shockwave followed. A pressure wave moving faster than sound, flattening forests, boiling lakes, creating winds strong enough to rip the skin off anything still alive to feel it. And then the earthquake. Magnitude 11, maybe higher. We do not have a scale for it because nothing like it has happened in human history. The entire planet rang like a bell. Seismic waves circled the globe. Volcanoes on the other side of the world, places that had been dormant for millions of years, suddenly erupted, triggered by the vibrations. Tsunamis a mile high radiated out from the impact site. They crossed the Gulf of Mexico in minutes, drowned the coastal plains, scoured the landscape clean, and when they reached the opposite shore, they did not stop. They climbed, carried inland by momentum and fury, depositing fish and shells and shattered trees hundreds of miles from the sea. Sarah the Triceratops did not see any of this. She was dead before the light reached her, vaporized, atoms scattered, every Triceratops within 2,000 miles, gone in the first 30 seconds. But that was just the beginning, because the impact threw trillions of tons of rock and dust into the atmosphere. Not the upper atmosphere, higher, into space. And what goes up has to come down. Within hours, the debris started to fall. Pebbles, boulders, molten droplets of rock, glowing red hot. They rained down across the entire planet. Everywhere. There was nowhere to hide. The sky was full of meteors. Thousands of them, millions of them, burning as they fell. And when they hit the ground, when they hit the trees and the dry grass and the forests that had somehow survived the initial blast, they started fires. Wildfires. Global wildfires. 60% of the world's forests burned. The smoke rose into the sky, mixing with the dust, creating a cloud so thick it blocked out the sun. And then it got dark. Not night dark. Darker. The kind of dark where the concept of light becomes a memory. Photosynthesis stopped. Just stopped. The plants could not see the sun. They started to die. And when the plants died, the herbivores had nothing to eat. And when the herbivores died, the carnivores had nothing to hunt. The food chain collapsed. From the bottom up. Within months, maybe weeks, most of the large animals were starving, and it stayed dark. For months. Maybe years. We are still not entirely sure, but long enough that when the dust finally started to settle, when the sky finally started to clear, and the sun finally broke through again, the world below was unrecognizable. 3/4 of all species on Earth were extinct. Every dinosaur larger than a turkey, gone. The flying reptiles, gone. The massive marine reptiles, gone. The ammonites, those beautiful spiral-shelled creatures that had lived in the oceans for 300 million years, gone. It was fast. That is the thing that gets me about this one. The Great Dying took 100,000 years. Snowball Earth took 10 million. But this was over in an afternoon. One moment, you are eating ferns. The next, you do not exist. There is something almost merciful about that. The speed of it. No long decline. No generations of suffering. Just a flash. And then nothing. If you are going to go, that is probably the best way. Quick. Clean. No time to be afraid. But what about the ones who survived? What about the creatures that were underground when the fires came? The ones in deep burrows or underwater caves, or just lucky enough to be in the few places the flames did not reach. They crawled out into a nightmare. Ash everywhere. The sky grey. The air full of smoke and sulphur, and the smell of burning. No sound, except the wind moving through charred stumps that used to be trees. No birdsong, no insect hum, just silence. And they were alone. Imagine surviving something like that. Imagine emerging from your burrow, hungry, confused, and finding everyone gone. Every familiar animal, every plant you used to eat, every landmark you used to navigate by. Just gone, replaced with ash and char and emptiness. What do? You keep going, I guess. Because what else is there? You find whatever scraps of food still exist. Seeds, maybe. Roots buried deep enough to survive the fire. Dead things. Lots of dead things. And you eat them, and you survive another day. And then another. The survivors were small. That seems to be the rule, does it not? The big ones die, the small ones make it. Not because they are better, just because they need less. Less food, less space, less oxygen, less of everything. And when the world is running on scraps, needing less is the only advantage that matters. There were mammals. Our ancestors, though you would not recognize them. Shrew-like things. Rat-like things, hiding in the undergrowth, eating insects and seeds and whatever else they could find. They had been around for 100 million years at this point, living in the shadows of the dinosaurs, never getting bigger than a badger because every ecological niche was already filled by something with scales and teeth. But now the dinosaurs were gone, and the niches were empty. And for the first time in 100 million years, mammals had room to grow. Not right away, not immediately. For a long time, for thousands of years, maybe tens of thousands, the world was still too broken, too unstable, too poisoned. But slowly, as the dust settled and the plants grew back and the air cleared, they started to diversify. New species, bigger species, species that could climb trees or swim in rivers or run across open plains, species that experimented with being active during the day instead of hiding from giant reptiles, species that, eventually, millions of years later, would evolve into primates, into apes, into us. We are here because the dinosaurs are not. Because an asteroid the size of a mountain happened to cross paths with Earth at exactly the wrong moment, or the right moment, depending on how you look at it. If that rock had been a few minutes earlier or later in its orbit, it would have missed, sailed past Earth, and disappeared back into the void. And mammals would still be small, nocturnal, insignificant, and humans would never have evolved. This conversation would not be happening. I would not exist to tell you about it. Everything we are, everything we have ever done, every city and song and story and scientific discovery, all of it exists because of a random collision 66 million years ago. Does that make you feel small? I think both. I think it is okay to feel both. Because here is what I take from this story. Life is fragile. Absurdly fragile. A 6-mile rock can end 160 million years of dominance in an afternoon. But life is also resilient. absurdly resilient. Even after 3/4 of everything dies, even after the sky turns black and the world burns, and the silence lasts for years, something survives, something continues, and whatever continues gets to try again, gets to evolve, gets to fill the empty spaces and become something new. The dinosaurs did not fail. They were extraordinarily successful. They ruled the planet longer than any group of land animals before or since. They adapted to every climate, every continent, every possible challenge except one. And that one was not their fault. It was not predictable. It was not something they could have prepared for. Sometimes the universe just says no. And there is no appeal, no second chance, no clever adaptation that saves you. You are just done. That is humbling. It reminds us that we are not inevitable, that our existence is not guaranteed, that we are part of a story much bigger and older and stranger than we usually allow ourselves to think about. But it also reminds us that the story does not end. It changes. It loses characters. It goes in directions no one expected. But it continues. The small mammals in the ash did not know they were inheriting the earth. They were just trying to find their next meal, just trying to stay warm, just trying to make it through one more cold, dark night. And that was enough. Enough to survive, enough to evolve, enough, eventually, to become us. So rest now. Let your shoulders drop. Let your jaw unclench. You do not have to carry the weight of deep time. You do not have to make sense of asteroids or extinctions or the randomness of survival. You just have to be here, breathing, listening, existing in this small pocket of warmth and safety that the universe, for now, is allowing. We are almost through. One more story, one more near miss, and then I will let you go, let you drift, let you sleep, if you are ready. But first, let us talk about something that might have happened. Something invisible, something from space that could have sterilized half the planet in seconds, something we would never have seen coming. Let me tell you about the time Earth was poisoned by the very thing that would eventually make us possible. 2.4 billion years ago. That is 2,400 million years. A number so large it stops meaning anything. But try this. Imagine every day of your life is 1 year. If you live to 80, that is 80 years worth of days. Now multiply that by 30 million. That is how far back we are going. The Earth then was not a place you would recognize. The continents were smaller, clustered together in strange configurations. The sky was not blue. It was orange. Maybe pink. Definitely not the color you see when you look up during the day. And the air, if you could even call it air, would kill you in seconds. No oxygen. Well, almost none. Trace amounts, the kind of levels you might find today in a sealed jar that has been sitting in a basement for a decade. Not enough to breathe, not enough to burn, not enough to matter, and yet the planet was alive, covered in life. Actually, the oceans were full of bacteria, trillions of them, microscopic organisms floating in the water, eating chemicals, reproducing, dying, being eaten, continuing. They had been doing this for over 1 billion years. They were good at it. They had the whole system figured out. And then one day, one species made a mistake. Or maybe it was not a mistake. Maybe it was the greatest innovation in the history of life, depending, again, on how you look at it. A group of bacteria, we call them cyanobacteria now, blue-green algae, figured out how to do something new, something no organism had ever done before. They learned to eat light, photosynthesis, the process of taking sunlight, water, and carbon dioxide and turning them into sugar, into food, into energy you can use to grow and divide and spread. It was brilliant, revolutionary, because sunlight is everywhere. It is free. It is constant. You do not have to compete for it the way you compete for chemicals or heat or space near a volcanic vent. You just float near the surface and soak it in. So, the cyanobacteria thrived. They spread across the oceans. They multiplied. They filled every sunny, shallow sea with their tiny green bodies. And as they ate the light, as they performed this miraculous chemical transformation, they produced waste. They exhaled. And what they exhaled was oxygen. Now, here is the thing you need to understand. Oxygen is not peaceful. It is not gentle. It is one of the most reactive elements on the planet. It wants to bond with everything. It wants to burn and corrode and break things down. It is, chemically speaking, aggressive. And for most of the organisms alive at the time, oxygen was poison. They had evolved in a world without it. Their entire biology, their enzymes, their metabolic pathways, everything was built for an oxygen-free environment. They were anaerobic. They did not need oxygen. They could not tolerate oxygen. And when oxygen started to appear in the water around them, their cells started to die. At first, it was not a problem. The oxygen the cyanobacteria produced just reacted with iron dissolved in the ocean, turned the iron into iron oxide, which sank to the bottom and formed layers of sediment. Banded iron formations, we call them now, beautiful striped rocks, red and black, that you can still find today in places like Australia and Minnesota. The ocean was bleeding rust for millions of years, slowly removing the iron, locking it away in stone. And as long as there was iron to react with, the oxygen did not build up. It just got used, neutralized, made safe. But eventually, after tens of millions of years, the iron ran out. There was no more left to rust, and the oxygen had nowhere to go. So it started to accumulate in the water first. Then, as the water became saturated, it started to bubble out into the atmosphere, rising up, molecule by molecule, breath by breath, until the air itself began to change. And the organisms that could not handle it started to die. Not all at once. Not in a single catastrophic event like an asteroid or a volcanic eruption. This was slower, quieter, a creeping apocalypse that took millions of years to unfold. Entire ecosystems collapsed. Species that had been dominant for hundreds of millions of years, that had survived every challenge the early Earth could throw at them, suddenly found themselves unable to survive in their own waste products, because that is what oxygen was to them. Toxic gas produced by an invasive species that was fundamentally changing the chemistry of the planet. We call it the Great Oxygenation Event, which sounds positive, does it not? Like progress, like something good. And for us, for anything that breathes air and depends on oxygen to power our cells, it was good. It was necessary. We would not be here without it. But for the organisms that died, for the 99% of anaerobic life that could not adapt, it was the end of the world. And here is the irony, the thing that keeps me awake sometimes, turning it over in my mind. The bacteria that caused this catastrophe, the cyanobacteria, they did not mean to. They were not trying to change the planet. They were not waging war or competing for dominance. They were just living, just doing what worked, just following the basic imperative of all life, which is to continue, and in continuing, they destroyed almost everything else. Progress is often violent. Innovation is often catastrophic for someone. The new world is built on the graves of the old one, whether we want to acknowledge that or not. But let me tell you what happened next. Because this is where it gets strange, where it gets almost beautiful, in a harsh, unforgiving kind of way. Some organisms survived. A few species of anaerobic bacteria found refuges, deep ocean vents, and they are still there today, billions of years later, living in the dark, metabolizing sulfur and methane, quietly continuing in the margins, while the rest of the world moved on without them. They did not win. Found a way to keep going in a world that no longer wanted them. And then there were the others, the ones who did something remarkable. They adapted. They learned to use the poison. I do not know how. No one does, really. But slowly, gradually, some bacteria figured out how to incorporate oxygen into their metabolism, how to take this reactive, dangerous molecule and use it to produce energy. And it turned out oxygen was incredibly efficient. Burning sugar with oxygen produces 15 times more energy than breaking it down without oxygen. 15 times. That is not a small advantage. That is the difference between walking and flying, between surviving and thriving. The organisms that learned to breathe, that figured out how to turn poison into power, suddenly had access to an energy source their competitors could not touch. They grew faster, got bigger, became more complex, and some of them, in one of the most important moments in the history of life, made a deal. A larger cell swallowed a smaller, oxygen-breathing cell. But instead of digesting it, instead of breaking it down for food, it kept it alive, inside, and the smaller cell kept doing what it did best, producing energy from oxygen. And in return, the larger cell protected it, fed it, gave it a safe place to live. We call those smaller cells mitochondria now. And they are inside you. Inside every cell in your body that needs energy. Billions of them. Ancient bacteria that used to be independent organisms, now living as permanent residents in your cells, powering your thoughts, your heartbeat, your breathing. You are not just you. You are a collaboration, a symbiosis, a walking, breathing reminder that sometimes survival is not about fighting. It is about compromise, about finding a way to live together, about turning an enemy into a partner. The oxygen crisis did not just kill, it created. It forced life to innovate, to adapt, to become something fundamentally new. Without it, without that catastrophic change in the atmosphere, complex life would never have evolved. No animals, no fungi, no you. Every breath you take is powered by a disaster that happened 2 billion years ago. Every thought in your head is fueled by bacteria that learn to breathe poison. Every moment of your existence is built on the ruins of a world that could not adapt. Does that make you feel strange? It should. It is strange. It is one of the strangest, most unlikely things about being alive. That we are made of compromises. That our cells are ecosystems. That our existence required a planetary catastrophe and billions of years of trial and error and countless extinctions. And yet, here we are, breathing without thinking about it, taking for granted the air that once killed almost everything. I think there is a lesson in that. Maybe several. One is that change is inevitable. You cannot stop it. You cannot preserve the world exactly as it is. The cyanobacteria could not be uninvented. The oxygen could not be put back in the bottle. Once the process started, it was going to run its course, whether anyone liked it or not. Another is that what looks like destruction from one angle looks like creation from another. The Great Oxygenation Event was the worst thing that ever happened to anaerobic life, but it was the best thing that ever happened to aerobic life. It is both, at the same time, and which one you see depends on where you are standing. And the third lesson, the one I come back to again and again, is that adaptation is possible, even when the change seems insurmountable, even when the new world is toxic to everything you are, even when every instinct says this is the end. Sometimes, if you are lucky or stubborn or just willing to try something new, you find a way through. Not the same way you were before. You cannot go back. The old world is gone. But maybe you become something different, something that fits the new world, something that uses the change instead of fighting it. The bacteria that learned to breathe did not become stronger versions of themselves. They became new. And that newness, that willingness to be transformed, is what saved them. I do not know if that is comforting or terrifying. I think it might be both, because it means nothing is permanent. Not the air, not the climate, not the conditions that allow us to exist. It could all change. It has changed before. It will change again. But it also means we are more adaptable than we think. That life, in general, is more resilient than it has any right to be. That even when the rules change, even when the game becomes something entirely different, something usually finds a way to continue. Maybe not us. Maybe not the species or ecosystems we love. And that something carries forward the story, builds on what came before, tries again. The oxygen is still here, by the way, still being produced by plants and algae and cyanobacteria, still filling the atmosphere at about 21%, still powering your cells, your thoughts, your ability to listen to this story. It is a gift. From organisms that have been doing this for 2 billion years, from a catastrophe that refused to be just a catastrophe, from the stubborn persistence of life, to turn every ending into a beginning. So breathe. Deep and slow, feel the oxygen flow into your lungs, into your blood, into your mitochondria, those ancient passengers that made you possible. You are alive because the world once died, because poison became fuel, because something small figured out how to continue when continuation seemed impossible. And maybe that is all any of us can do. Figure out how to continue, how to adapt, how to take the world as it is, not as we wish it were, and find our place in it. The anaerobic bacteria in the deep ocean are still there, still thriving in their refuges. They did not defeat the oxygen. They just found where it was not, and that was enough. Sometimes survival is not about winning. It is about finding your crack, your margin, your place where you can still be yourself, even when the world has moved on. And sometimes it is about changing, becoming new. Both are valid. Both are ways of saying, I am still here. I am still trying. The story is not over yet. Let your breath slow now. Let the weight of 2 billion years settle around you like a blanket. You are safe. You are held. You are breathing air that was once poison, and it is keeping you alive. That is a kind of magic. A small, everyday miracle. One more story. One more near miss. Back to the simple fact that you are here, and that is enough. This one is different. The others, the ice and the fire and the asteroid and the poison air, those happened. We know they happened. We have evidence. Rocks, fossils, chemical signatures locked in ancient sediment. The Earth keeps records, if you know how to read them. But this story, this last near miss, exists in the space between what we know and what we suspect, between evidence and imagination, between science and mystery, and maybe that is fitting. Because sometimes the most frightening thing is not what happened, it is what might have happened. What could happen still? Let me tell you about gamma-ray bursts. Somewhere in the universe right now, a star is dying. Not our sun. Some other sun, thousands of light years away, massive, ancient, running out of fuel. For millions of years it has been burning hydrogen, fusing atoms, fighting against its own gravity. But now, the fuel is gone. The core collapses, and when a star that big collapses, when all that mass compresses down into a space smaller than a city, the universe does something extraordinary. It explodes. A supernova, one of the brightest events in the cosmos. For a few weeks, that single dying star outshines its entire galaxy. Billions of stars. And this one dead thing is brighter than all of them combined. But sometimes, if the star is rotating just right, if the collapse happens in a specific way, something else occurs. Instead of exploding in all directions evenly, the energy focuses, concentrates, shoots out in two narrow beams from the poles, gamma rays, the most energetic form of light in the universe, more energetic than X-rays, more energetic than ultraviolet, so energetic they can pass through solid matter like it is not even there. And these beams, these focused streams of radiation, tear through space at the speed of light, brighter than anything else happening in the universe at that moment. We call them gamma-ray bursts, and if one happened to be pointed at Earth, if we happened to be in the wrong place at the wrong time, when a star thousands of light years away decided to die, we would not know it was coming, because it travels at the speed of light. The warning and the disaster would arrive at the same moment. You would not see a flash in the sky and have time to take cover. The light that told you it was happening would be the light that killed you. Not directly. Gamma rays do not vaporize you like an asteroid impact. They do not burn you like volcanic fire. The effect is subtler, more insidious. They hit the upper atmosphere, interact with nitrogen and oxygen molecules, break them apart, recombine them into nitrogen dioxide, a brown, toxic gas. And nitrogen dioxide is very good at one thing. It destroys ozone. Ozone, that thin layer of 3 oxygen atoms bonded together, floating in the stratosphere, absorbing ultraviolet radiation from the sun. The shield that makes life on land possible. Without it, the sun's UV light would sterilize the surface. shred DNA, make photosynthesis impossible. A strong gamma-ray burst, aimed directly at Earth, could strip away half our ozone layer in seconds, and it would take years to recover, maybe decades. During that time, the sun would cook us, slowly, quietly, invisibly. Plants would wither, plankton in the ocean, the base of the entire marine food chain, would die. Skin cancer rates would skyrocket. Mutations would increase. Ecosystems would collapse from the bottom up, not an instant apocalypse. A slow one. The kind where you wake up each day and the sky looks normal and the sun looks the same, but everything is just a little bit worse than it was yesterday. And you cannot fix it. You cannot adapt fast enough. You just have to endure it and hope something survives. So did it happen? We do not know. But there is a moment in Earth's history that makes scientists wonder. That keeps them up at night, running models, checking data, looking for patterns. 450 million years ago. The Ordovician extinction. Not as famous as the Great Dying or the asteroid, but still significant. 85% of marine species gone. Suddenly, mysteriously, the pattern fits. The extinction happened in 2 pulses. The first killed organisms in shallow water. The second killed organisms that had moved deeper, seeking refuge. As if something from above was hunting them, pushing them down until there was nowhere left to hide. And the geologic record shows something strange. A spike in certain isotopes. Evidence of cosmic radiation hitting the atmosphere. Evidence of ozone depletion. Not proof. Not certainty. But a suggestion. A whisper. A possibility that something out there, some dying star we will never know the name of, briefly turned its gaze toward Earth and nearly ended us. It is frustrating, is it not? Not knowing. Having a mystery with no definitive answer. We like our stories complete. We like our disasters explained. But the universe does not owe us closure. Sometimes things happen, and we can only guess why. Sometimes the evidence is ambiguous. Sometimes we have to live with uncertainty. And honestly, I find that oddly comforting, because it means we do not have all the answers. It means there are still questions, still mysteries, still things we do not understand about our own history, our own survival. It means the story is not finished, not wrapped up, not solved. It also means that right now, as you are lying here listening to this, there could be a gamma-ray burst traveling toward us, launched 1,000 years ago from a star that died when castles were being built and empires were rising and falling, and no one had any idea what a gamma-ray even was. It could arrive tomorrow, or in 100 years, or never. We would not know until it happened. And by then, it would be too late to do anything except deal with the consequences. Does that scare you? It should not. Not really, because here is the thing. The universe is vast. Incomprehensibly vast. The number of stars is so large it might as well be infinite. And the number of those stars that will produce gamma-ray bursts, and the number of those bursts that will be aimed in our direction, and the likelihood that one will happen close enough and pointed precisely at us, is vanishingly small. Not impossible. But so unlikely that worrying about it is like worrying about being struck by lightning while simultaneously winning the lottery while a meteorite lands on your house. It could happen. But it probably will not. And even if it does, even if somewhere out there a star is collapsing right now and one of its beams is pointed our way, there is nothing we can do about it. No technology advanced enough to stop light itself. So what is the point of worrying? The universe is mostly indifferent. That is not cruelty. That is just reality. Stars do not care about us. Gamma rays do not have intent. They just are. And we just are. And sometimes those 2 facts intersect in catastrophic ways. And sometimes they do not. And we have been lucky so far. 4.5 billion years, and no gamma-ray burst has sterilized us. No nearby supernova has cooked us. No wandering black hole has swallowed us. We have been safe, not because we are special, not because we are protected, just because the dice, so far, have rolled in our favor. And maybe that is the real lesson here. The real takeaway from all of these stories. Survival is not about deserving. It is not about being the best or the strongest or the most prepared. It is about luck, timing, being in the right place, or more accurately, not being in the wrong place. The dinosaurs did not deserve to die. The trilobites did not deserve to go extinct. The 96% that vanished in the Great Dying were not failures. They were just unlucky. And we are not here because we are better. We are here because our ancestors were lucky, because the asteroid missed them, because they were small enough to hide, because they happened to have the right metabolism when the air changed, because no gamma-ray burst happened to be pointed at us during a critical moment in our evolution. We are the descendants of the lucky ones. And that is humbling. It reminds us that we are fragile, that our existence is contingent, that the universe does not owe us tomorrow. But it is also freeing, because if survival is mostly luck, then failure is not always our fault. Sometimes things just happen. Sometimes the world changes in ways we cannot control. Sometimes we do everything right and still lose. And that is okay. That is just how it works. The organisms that died in the Ordovician extinction, if it was a gamma-ray burst that killed them, did nothing wrong. They were just alive at the wrong time, and the ones that survived were not heroes. They were just in deeper water, or had better UV resistance, or got lucky. No moral, no lesson. And yet, life continued. The survivors evolved, filled the empty niches, became new things, and eventually, millions of years later, here we are. So maybe the lesson is not about preparation or strength or resilience. Maybe it is about acceptance, about recognizing that we are part of something much bigger than ourselves, something we cannot control, something that operates on timescales and distances that make our lives feel like flashes. And in the face of that vastness, in the face of that indifference, we still matter, not to the universe, but to each other. Your life, right now, this moment, matters, not because it is permanent, not because it is safe from disaster, but because it is happening, because you are here, because consciousness, awareness, the ability to wonder about gamma-ray bursts and frozen planets and dying stars is rare, precious. You are a temporary pattern of atoms that happens to be aware of itself, and that is miraculous, especially because it could end tomorrow. So, take a deep breath, let it out slow. Feel the weight of your body against the mattress. Feel the gravity holding you to this spinning rock. Feel the warmth of your own skin. You are here. Now, in this moment, safe, breathing, thinking. No gamma-ray burst has found us yet. No asteroid is scheduled. No supervolcano is erupting. The ice is not advancing. The oxygen is still flowing. Right now, in this moment, you are okay. And maybe that is all we ever have. This moment, this breath, this quiet space between disasters, where we get to exist and wonder and tell stories about how we almost were not. The universe is vast and dangerous and indifferent, but it is also beautiful. And we get to be part of it. That is enough. That has to be enough, because it is all we have. And it is everything. Let your eyes close now, if they have not already. A reminder that you are part of something ancient, something ongoing, something that refuses to end. We are almost done, almost home. And then I will let you go, let you drift, let you rest in the knowledge that you are here, and you are held, and the story continues. For now, for this moment, and that is enough. So here we are, still here, after all of that, after the ice and the fire and the poison and the silence, after asteroids and gamma rays and oceans that bled rust, after 96% died and the sky went dark and the world forgot what warmth felt like. Still here, you and me, having this conversation, across time, across distance, across whatever strange path brought you to this moment, lying in bed, listening to a stranger tell you about the end of the world, except it was not the end, not any of those times. It came close, closer than seems possible, closer than seems fair, but it did not end. And tonight, right now, Outside your window, the world is still turning. The air is still breathable. The temperature is still, more or less, tolerable. The sun will rise in a few hours, the way it always has, the way it has for 4.5 billion years. These are not small things. They are everything. The fact that you can breathe without thinking about it. The fact that the sky is not frozen solid or choked with ash or stripped of its protective layer. The fact that there is food to eat and water to drink and ground solid enough to stand on. We take it for granted. We have to, I think, or we would spend every moment paralyzed with gratitude and terror. But every now and then, maybe late at night when the world is quiet and your mind will not settle, it is worth remembering. You are breathing air that used to be poison, walking on ground that used to be ice, living in a window of time between catastrophes. A brief, improbable moment when the conditions happened to be right, and you did not do anything to earn that. None of us did. We are just here, lucky, temporary, alive. I do not know what you are supposed to do with that information. I do not think you are supposed to do anything with it. Honestly, you do not have to be inspired. You do not have to feel grateful or motivated or changed. You can just let it sit. Let it be. A fact among other facts. A story you heard once, late at night, when you could not sleep. Because here is the truth. I make these videos for nights like this. For people like us. The ones who are awake when we probably should not be. When your mind will not stop and your body will not settle and you just need something. Something bigger than tomorrow's problems. And sometimes I make them because I cannot sleep either. Because I lie awake thinking about frozen bacteria and dying stars and all the ways the story could have ended, but did not. And it helps, somehow, to speak it out loud, to shape it into words, to send it out into the world and hope it finds someone who needs to hear it. So, if you are still listening, thank you for being here, for trusting a stranger's voice to guide you through deep time and disaster and back home again. I hope it helped. Even a little. Even just by filling the silence. And if you are ready now, if your body is finally willing to let go, then let yourself sink into the pillow, into the mattress, into the same planet that held those bacteria under the ice, that held the 4%. That holds you now. You are safe. You are held. You are part of something that refuses to end. The Earth has survived everything. Ice ages and infernos, asteroids and eruptions, oxygen crises and ozone depletion. It has been frozen solid and burned to ash and poisoned by its own atmosphere. And it is still here, still turning, still breathing, still creating and destroying and continuing. And you are part of that. Made of the same atoms, following the same story, carrying forward the same stubborn insistence on existing that brought us through every other impossible moment. You do not have to be strong. You do not have to be brave. You just have to be here. That is all life has ever asked of anyone. Just continue. Just show up for one more day, one more breath. And if you can do that, if you can make it through tonight and wake up tomorrow and keep going, then you are doing exactly what every ancestor you have ever had did. What every organism that survived the Great Dying did. What those bacteria under the ice did. You are continuing the story, not because you are special, not because you are chosen, just because you are willing. So let your breath slow, let your thoughts drift, let the darkness be a blanket instead of a void. You have walked through 4 billion years tonight. You have seen the worst days this planet has ever known, and you have come back. You are here, in this moment, in this bed, in this brief, beautiful, improbable window of calm. Nothing is chasing you. Nothing is ending. The ice is not coming. The fire is not burning. The sky is not falling. Right now, you are okay. And maybe, if you are very still, if you let everything else fall away, you can feel it. The weight of deep time beneath you. The long chain of survival that stretches back to the beginning. Every creature that held on just long enough to create the next generation. Every lucky accident. Every narrow escape. They are all here. In you. In your cells. In the mitochondria that power your thoughts. In the oxygen you breathe. in the atoms that make up your bones. You are not alone. You have never been alone. You are the latest chapter in the oldest story, and it is not over yet. So, sleep now, if you can. Let yourself go. Let the weight of it all lift. You do not have to carry the history of the world. You do not have to solve the mysteries or prevent the disasters or make sense of the randomness. You just have to rest, because you have earned it. Just by being here, just by listening, just by making it through another day in a world that is still, against all odds, turning. Good night. Or good morning. Wherever you are in the turn, we made it through the ice, through the fire, through the silence, through the poison, through the impact and the darkness and the uncertainty. We will make it through tonight too. Sleep well. You have earned it. And tomorrow, when you wake, the sun will still be there. The air will still be breathable. The ground will still be solid. And the story will still be continuing, with you in it, right where you belong. Rest now. You are home.